In this lab, we're going to be looking at the heat change that takes place during a chemical reaction. So we're going to conduct this reaction by dropping in small pieces of magnesium into hydrochloric acid, and our products are magnesium chloride and hydrogen gas, but we're really not interested in these products as much as we are interested in how much heat is released. And we're going to measure that and report it per mole of magnesium. So if we were to do the reaction with an entire mole of magnesium, as this balanced equation implies, then how much heat would be released? You would see this reported as a delta H value. This particular reaction is exothermic, so heat is going to be given off. And for exothermic reactions, we show the delta H with a negative sign. So what we're going to be looking for is how much heat is released that will eventually be reported as kilojoules per mole of magnesium. So we're going to do the reaction 3 times, and in each trial you're going to vary the amount of magnesium. So obviously the more magnesium you use, the more heat will be released, and in this case the more temperature will go up. So we're actually going to be measuring the heat by measuring the temperature. So I'm going to walk you through the calculations for one of the trials, and then of course you would just repeat this same series of calculations for the other trials. Alright, so I'm going to refer to this by the letter notation that you're asked to report in the lab. So when you get to part D, you're asked to report the change in the temperature. So we're really interested in how much the temperature goes up. This is what we're interested in, the delta, how much does it change. So with your thermometer, you're going to measure the temperature at the end. Final will be higher than the temperature initially, so you'll subtract those and figure out how much the temperature goes up. Part F, in part F, for some of our calculation, we're going to need to know how much stuff, the contents in your calorimeter. So the reaction actually takes place in this little insulated device, which you would recognize as a styrofoam cup, and we want to know just what's inside of it. So like we have to do many times when we're wanting to know how much stuff we have to know the mass of the container with the stuff, with the contents, and then we do what we always do, and that is subtract out the mass of the empty calorimeter. Alright, so this data you'll be collecting, and actually you're specifically going to report the mass of the empty calorimeter in part A, and then at the end of your experiment you're going to measure the mass of it, and that will be reported as part E. So we're going to use those two pieces of information to find part F. We want to know what's inside the calorimeter, and this is actually the value that we're going to use in the heat calculation. For part G, you're going to be working with the mass of magnesium. So it's just the small piece of magnesium that you are told to use either in the virtual lab, you're given a specific amount, or in the real lab, your small piece of magnesium, you need to report the mass of it, and that'll be in grams. But you also, in part G, need to convert grams of magnesium to moles of magnesium. So of course that's just a molar mass conversion. So you'll need to find moles as well. So be sure you report in part G the mass as well as the equivalent mole value. Both of those should be reported in G. Moving on to the calculation in part H, This is where you're actually going to calculate heat. So heat has to be calculated. It's not something that we can just stick a heat probe in there and measure the joules or kilojoules. So we have to use this relationship in order to calculate heat. So M is specifically the mass of the contents in your calorimeter, which we just found in part F. Delta T is how much the temperature changed during the reaction, which we just found in part D. And then we multiply that by the specific heat of the substance that we're warming. And since the substance that we're warming is mostly the solution inside the calorimeter, we're going to be using the specific heat of water. This is very close to water's specific heat. And when you do this multiplication, of course, grams are going to cancel and degrees Celsius are going to cancel, and you're going to have a value reported in H as joules. This is going to be going to vary for each trial because the temperature change will vary. The mass will vary a little bit, but as the temperature goes up more, the heat released is going to be higher. When you get to part I, though, we're going to find the actual heat per mole of magnesium. So here you're going to take the value that you found in H, the joules, and divide them by moles of magnesium that you found in part G. And so what we're doing here is converting this to a value if you had done the reaction with an entire mole of magnesium. So what you should find is your values in H are going to vary, but when you convert them per mole of magnesium, all three of your I values should be pretty close to each other. So there shouldn't be a lot of variance in your three I values. Then you're going to take those three values that you find in part I and you're going to average those. And so that's the last thing that you're asked to do, is report an average delta H for the reaction. It's acceptable at this time to go ahead and probably convert the joules. This is going to be a really large number because joules are very small energy units. So it's appropriate to go ahead at this point and convert your value to kilojoules per mole of magnesium. And this is how you can report your final answer as an average of those I values, but you can go ahead and convert them to kilojoules.